Giant covalent structures are made up of many atoms joined by covalent bonds, and many are formed into lattices. We are going to explain to you a few of the ones that you need to know about, such as diamond and graphite, as well as a few extra ones. Diamond and graphite are both allotropes of carbon, meaning they are both made out of carbon atoms but in different structures. Firstly, we will look at diamond. Each carbon atom is joined to other atoms by 4 covalent bonds. There are no free electrons, so it cannot conduct electricity and is also insoluble in water. Its structure makes it one of the strongest natural substances, which is why it is often used as a cutting tool. It also has a very high melting point due to the strength of the bonds. The second allotrope of carbon is graphite. Graphite is instead formed in layers, and this can also be seen when you look at a piece of graphite, such as slate for example. There are only 3 covalent bonds, meaning there is a spare electron per atom. Free electrons mean that graphite is a good conductor of electricity. The yellow lines here represent the weak van der Waals forces which loosely join the layers, but still allow them to slide off of each other. However, it still has a high melting point, as the 3 bonds are still very hard to separate. Because of this, graphite is used in pencil lead and lubricants as the layers easily slide off of each other. There are a few other covalent structures which we will mention. First is silica, which is similar in properties and structure to diamond, but is instead made up of silicon and oxygen atoms and is found in sand. Other allotropes of carbon are called fullerenes, one of which is Buckminster fullerene, which you may also know as a buckyball, like this. It is made up of 60 carbon atoms arranged into hexagons and pentagons, which make up this buckyball shape.